All right, today we're gonna cover three sections. We're gonna cover section 7.4, 7.5, and 7.6. And the previous sections to this have been solving systems of equations by graphing, or the addition method, or substitution. And this section is supposed to be about how you choose which one of those. And we're going to do some word problems in this section too. So, graphing. When we use graphing, graphing is, again, for me, just a nice method to start with to give you an idea that when you're solving a system, you're looking for an intersection of graphs. Substitution method is a great method when one of the variables has a coefficient of 1 or negative 1. And the addition method is good when you don't have variables that are 1 or negative 1. It's usually a little bit easier to do that than substitution. So here's a typical mixture word problem that's going to end up giving us a system of equations. So I wanted to give you an example because this is one you'll be able to use quite a bit. Mixture problem. So a chemist needs to make 30 ounces of a 25% alcohol solution. So that means that in that solution, 25% of it will be alcohol, 75% of it will be water. And the way we're going to mix this together is we have a 15% solution and a 40% solution. So we're going to have to mix the 40 and the 15 together. And the question is, how much of each do you have to put in order to make exactly 30 ounces? So the first equation of the system that you're going to make is going to be of the form x plus y equals the amount. And really what we're saying is x is going to be how much of the 15% solution we're going to put in. Y is going to be how much of the 40% solution we're going to put in. And the amount then is going to be how much we're looking to make total, which in this case is 30. So x is the amount of 15%, y is the amount of 40%, and if you add up how much you're going to put in of the 15 and how much you're going to put in of the 40, they have to add up to 30. The second equation is going to be the percentage equation, and we can see right here that the amount of 15% solution, so the x number is the amount, is being multiplied by the potency of that solution. It's only 15% of alcohol, or 15% of whatever we're looking at. In this case, it happens to be alcohol. So the 0.40 represents the 40% solution, and the y is how many ounces of that 40% solution. And then right here where we get to the 0.25, the 0.25 times 30. Well, the 30 represents how many ounces we're going to have total, and the 0.25 represents how much the potency is. And when we multiply the 0.25 times 30, we're going to get that 7.5. So that's our second equation. So now we have two equations, two unknowns. Our first equation is the amount equation, x plus y is 30, and our second equation is really the potency equation. And at that point, we would choose a method for solving. So this is probably one where we would choose to use substitution. So section 7.5 is all about the different kinds of solutions that you can have when you solve a linear system. And so what I'm talking about here is that you can either have one solution when the lines intersect in your system, or you can have no solution when the two lines are parallel, or you can have infinitely many solutions when the lines are the same line. And this is the only way that you can have two equations interact in the plane. So you can have one solution, no solutions, or infinitely many solutions. So one of the ways that we can find this out is by just looking at a graph. Another way is to solve them algebraically. And anytime we solve a system algebraically and all the variables disappear, we're either going to have a no solution or we're going to have an infinitely many solutions. And if it's a true statement when the variables disappear, then there's infinite solutions. And if it's a false statement when the variables disappear, there are no solutions. So here's an example of what we mean by that. So here we have two equations, negative x plus 2y equals negative 2, and 3x minus 6y equals 6. So we'd start off and we'd choose a method for solving here. I think if I was choosing a method for solving, I would probably choose the addition method. So I'm going to multiply the top equation by 3, and when I multiply that top equation by 3 and I add them, I'm going to get 0 equals 0. So this is a case where the variables disappear. When the variables disappear, we either have a no solution or an infinitely many solutions. In this case, since the equation is true, since the statement is true, the lines are on top of each other. They're the same line. So we have infinitely many solutions. Here's another example, different problem. And in this one, it looks like I might want to use substitution because the y in the second equation is by itself. And if I use substitution and I plug it in, what I'm going to get when I simplify the left side, I'm going to get negative 24. So when I have 6x minus 2 times 3x plus 12, that ends up being negative 24. And since the negative 24 isn't equal to the 10, we have a statement that's not true. And when the statement is not true, that's a no solutions problem. And again, what does that mean? It means that the lines are parallel. All right, so section 7.6 is on solving systems of linear inequalities. And when I think of solving systems of inequalities, what I think of is always that there's going to be shading. So that's the difference between solving a system of two equations and an inequality is some shading. So we still are looking for ordered pairs that will be the that will make the inequality true. That's how we're going to test our system. So we're going to graph our linear systems, and we're going to see where is a point that makes all of them true. I really love this example right here because it starts off with x is less than 4, and that makes a lot of students uncomfortable because there's no y equals mx plus b there. But of course, when we have just one variable, that means it's either going to be a horizontal line or a vertical line. And in this case, it's going to be a vertical line because x is always going to be on that 4. Now, it's a dotted line, and it's a dotted line because we have an inequality. There's no equal sign there. And that is going to tell us that when there's no equal sign, the answer is going to start there, but doesn't include there. Now, once we plot our line, the next thing we're going to do is we're going to test a point. Most of the time, I like to test the point 0, 0. Does the 0, 0 make the inequality true? So when I use 0, 0, the x value is 0, so I plug in 0 for x. Is 0 less than 4? It is. That means this point makes the inequality true, and therefore every other point on this side of the line makes the inequality true. So I usually just draw one little arrow to indicate that. Then I'm going to go ahead and graph the next inequality, and the next one is going to be y is greater than or equal to negative 3. Same thing, no x value here, just 1, and so this is our horizontal line. And when I go ahead and do the shading on this one, I'm going to pick that very same point. I'm going to go back and I'm going to pick 0, 0 as my point. Is 0 greater than or equal to negative 3? It is not. 0 is not, or is it? Yes, it is. So 0 is greater than or equal to negative 3, and therefore we're going to be shading above the line. All right, so after we know that we're shading above the line, now it's time to finish with the black equation. And I'm just going to plug and chug here to make the black equation. And, you know, that's what it's going to look like. The y-intercept is going to be at negative 4, and it looks like, you know, the slope is up 1 over 1, up 1 over 1. And now we have 3 equations graphed. And when I check a point on here, if I check the point 0, 0, when I check the point 0, 0, is 0 minus 0 greater than or equal to 4? Well, it's definitely not. So therefore, the other side of the line is being shaded. So in this case, we're shading the left above and the right, and that's going to be this section right in here. And that's how we graph a system of inequalities. And of course, you know, I always think it's interesting that we have a bounded region here, and yet there's an infinite number of ordered pair solutions in that region. And guys, that's why we graph. The reason that we graph a system of linear inequalities is that if I asked you to list every ordered pair that would make this system true, you could never list them all, because there's an infinite number of ordered pair solutions. The graph allows us to show all those solutions. The graph can show the infinite number of solutions, and that's why we take the time to graph these. Okay, so that's the last section in Chapter 7, and we've learned how to solve linear systems by graphing, substitution, and the addition method, and we've learned how to do systems with linear inequalities.